Hi, welcome back to LeetCode. So in this video, I'm going to discuss LeetCode problem 3644. Maximum k to sort a permutation. You are given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n-1. You may swipe elements at indices I and j only if nums of I and nums of j equals to k. So here n denotes the bitwise AND operations and k is a non-negative integer. So we would return the maximum value of k we can use to sort the array. So in which order? In non-decreasing order. So we can do any number of swipes, and if number is already sorted, return 0. So that means they've already mentioned that our elements will be between 0 to n-1. Now they are saying that we have to sort in the order of non-decreasing. So all the number actually already unique, because suppose n is equal to 3. So number will be 0, 1, 2. Now they are mentioning that we will sort according to the with respect to non-decreasing order. So non-decreasing means first it will be 0, then 1, then 2. So ultimately this actually not a non-decreasing, it will be actually increasing order, because all the number actually is unique. Got it? Now we have to find out k such that if I have to swipe two element nums I and j, index I and j, so then actually nums of I and nums of j and value will be k. Clear? Now how actually we can identify that which number actually will be placed what, or with which number I have to swipe. So for this example 1, you can see that our input array is 0, 3, 2, 1. So our target n is equal to actually 4. So element will be 0, 1, 2, 3. So this is your target vector. So this will be 0, 1, 2, 3. So you can see that 0 is already in the target position, 3 I have to swipe here, 2 is already in target position, 1 actually I have to swipe here. So ultimately I have to swipe 3 and 1. Right? Now, so for the binary representation of 3, it actually 1, 1, and binary representation of 1 is 0, 1. So if I do the AND operation, it will be 0, 1. So this will be our k, maximum k value, correct? So for this example, the k value it is 1. You can see that the output is 1. Okay. So how will you choose the k, maximum k? So you can see that one property is here. Suppose this actually our u and this is v. So u and k and v and k, what actual value actually I will get? So u it is 1, 1, 1, and k actually is 0, 1. So if I do the AND operation here, so again this is actually 0, 1. Okay. For v it is actually 0, 1, and k value is again 0, 1. So I'll get 0, 1. You just see here there's observation that both are actually k. Here also the k, here also the k. So that means whatever the actual value actually I have to swipe, that value with k, I will get actually ultimately k. Right? So that means k will be a common value. Suppose we actually have another vector 0, 2, 1, 4, 3. So our target vector will be what? 0, 1, 2, 3, 4. So this is already sorted. This number I have to swipe, 1 actually I have to swipe, 4 also I have to swipe, 3 also I have to swipe. So maximum k, what actually I can choose? So I know that I have to swipe with 1 and 2, then I have to swipe 3 and 4. Correct? So 1 and 2, so binary representation is 0, 1, 2 value is 1, 0. So k value actually I can choose that actually 0. Okay. 3, for 3 and 4, the binary representation of 3 is 1, 1, 1, and 4 it is actually 1, 0, 0. Correct? So this will be ultimately 0. So k value actually I can choose the maximum or minimum, all of this, that actually 0. Clear? So for this example, our output will be 0. Clear? So now how we can solve this problem? So first of all, our target is to maximize the k value. So what is your we should actually iterate from maximum of k to minimum of k. So what is the maximum value actually I can actually get? So after using that, actually I will check that I'll actually swipe all the elements or not, right? So maximum k value will be what? So they mentioned that our maximum element it will 10 to the 5, right? So how many bit actually record? It record roughly 17 bits. Now in the maximum k value will be what? All the bits actually I have actually set. So that means all the 17 bit actually are set, right? To represent 10 to the 5, actually I need actually 17 bits. So this will be maximum k value, and minimum k value will be 0. All the value which is not set. Now for that, I have to identify that which number I have to swipe. So current answer our start it will be from 2 to the power 17 minus 1. Got it? This is the maximum value. Now, um, now I'll. This is our current answer. What actually answer actually I have? This is suppose our current k. Now for this k, what actually I have to do? I will check that by using k, which number actually I have to swipe. So for that, I will actually swipe for I is equal to 0, I less than n, I plus plus. So I know that this is your target current number present in the I, that actually the should be I only, right? Because you can see that each index I, this actually I, index value is also I, and the current number is also I. Here also the index value is 1, value number is also 1, index is 2, the value is also 2. So I will easily check that if it is current I is suppose 0, I am starting from here. So next I will be nums of I, that means nums of 0. So this is already 0, so this is already visited, so there is we do not need any operation to swipe. Next is I is equal to 1. So next I will be what? Nums of I, so that means nums of 1. So nums of 1 it is 2, so our next I will be 2. So that means I need to swipe current number with the index 2. So that next I will be nums of 2. So this actually again index 2 I actually have 1. So this one actually I have already visited. So I'll stop here. So what is the k value actually I can choose? Whatever the k actually currently I have k and the current number 2, because this number actually I have to swipe. Next I have to swipe k with whatever the k actually I will get, that number actually again I have to swipe with 1, right? So that means what is the common k, that will be our ultimate answer. Clear? Suppose let's see this example 0 1 2 0 1 3 2 0 1 3 2. So our target is 0 1 2 3. So I am starting from here, I is equal to 0. Next I will be nums of 0. Nums of 0, this is already 0, so I do not need to do any swipe. So k is still max, or 2 to the power 17. All the bit actually set. Next I is equal to 1. So next I will be nums of 1. Nums of 1, this is already sorted, so this is again 1, so I'll stop here. Next I is equal to 2. So next I will be what? So it should be placed here, but if the current in the input array, if it is not the current value, so it will take into another index, so that will be nums of 2. So that actually nums of 2 it will present as 3. Okay, so next is I is equal to nums of 3. Nums of 3, 0 1 2 3. So this actually 2. So 2 actually I already visited here, so I'll stop here. Next is I is equal to 3. So that actually I already visited this here actually, so I do not need to do anything here. Now you can see that for these two, I have started with k is equal to max 2 to the power 17. Suppose now what to do? I will know that this number with this number 3, I have to actually swipe. So this I have already shared the properties u and k, it will should give k. So that's whatever k actually I have, I will actually do the k with the current number 3. Next I'll suppose get k1. So it should actually give the k, right? K1 should be equal to k. Next is what are the key actually I have, that should be, we have to do the AND operation with 2, that should be equal to k. Clear? So in this actually I will ultimately check what is the maximum key actually I can do, I can actually get. So now what is the code? So first of all I will take a vector of scene to, like I already processed here actually 3, this 3, index 3, because of the index 2, because it will actually take me into the index 3, so I have to swipe, so I have already calculated this time. So that's why I'll take a vector to handle duplicate. So that's initially it is false and there is n numbers, so that indicates that this index is visited or not, and our initial answer will be 2 to the power 17 minus 1. So I have already explained why actually 17, because to represent the 10 to the 5 I need actually 17 bits. You can see also. Now this found cycle actually it is false initially, so this indicates that this is already sorted or not. If it is not sort, if it is already sorted, so that time this will not be modified, this answer will not be modified, I will actually the maximum answer, so that time I should return 0. So that's why to check that have I actually got any conflict position or not. So that's why I will track this by using this variable. So now actually I'm iterate from index 0 to n minus 1. So I'll see that first of all that this index is I have already visited or not. So how actually I can visit it? You can ask that I am actually visiting from left to right. How can it possible that I visited already this index before? This is possible because it may possible that in the previous I got any position that actually we need to swipe in the current index I. So that time I have to visit at that time only. So that's why I'll check this. If it is true already, so continue. Next is current position is I, and cycle current answer is current key. You can say that the answer, whatever actual answer I have, and length is 0. Got it? Next I'll see I have to continue till actually I have not visited this place again. So I'll see that the current position seen of current index it is still false. I'll continue. So what actually I will do in the while loop? So I'll first of mark the current position as true because I will not visit this again, and next current cycle and will be whatever actually the with the current number actually I have to swipe. Got it? And also the next position will be what? Like here actually you can see that first index is 3, so this is not visited. So next it will take me to this index 3, correct? So this is also not visited. So k and 3 first of all, then k and 2. Got it? So that's why first of all do the AND operation with the current number 3 with respect to that example, and go to the next number. Next index will be what? What are the value actually I have? Index 3. So it will took me to the index 3 whose value is now 2. Right? I have to swipe that value with that two number 3 and 2. So current will be now, next index will be nums of current. Got it? And length plus plus. Length indicates that if the length is 1, that means there is no cycle. There is no cycle means there is this is already in the target position. Got it? And length plus plus. So it will actually continue till actually we will actually found the which number actually I have to swipe. Right? Now I will check that if the length is greater than 1, that means there is some conflict position. I have to swipe that. We need actually swipe operation. So I have to swipe that. So found cycle it will be true. Okay, and answer will be what? Minimum k. Minimum of the current answer I have, and the k ultimately after this operation. So because anyway this k will be minimized, because it may possible that ultimate k value will be, all the values should be k. Like there are 4 elements I have to swipe, like suppose n1, n2, n3, n4, and there is only one common k. So that means n1 and k it should be equal to k, n2 equal to k it should be k, n3 and k it should be equal to k, n4 and k it should be k. Got it? So that's why I have to take only the common k, right? And this should be minimum of all of this. Suppose this is actually possible with k1, here actually k2, k3, k4. So I have to choose the minimum k, because then it will be actually common for all. Clear? So that's why I'll choose the minimum k. And ultimately before returning the answer, I'll check that have I actually found any cycle. Found cycle means is there any conflict position? I have found any conflict position. If it's still false, that means there is no conflict position. This is already sorted. Return answer 0. If it is true, that means we have found some conflict position. So whatever the actual answer actually I have k, so return that directly. Got it? I actually handle this situation that also this is already sorted. I hope this is clear. And if you found this video useful, please like the video. And if you're not a subscribe, please subscribe channel. You can comment if any suggestion also. Thank you.